Okay, I'm going to spend some time here going over yesterday's homework, and I would strongly suggest that you watch and follow along, especially if you struggled on yesterday's assignment, because today's is using the same skills, so some of it will be the same, but they get a little bit more complicated because we'll have exponents on both sides with our variables on both sides that we have to solve for. All right, so the idea of this is we're solving using logarithms. So we've got two options. We can rewrite this in logarithmic form, or we can take the same base log of both sides. So just because you're going to do this here with today's assignment and have to do the log of both sides, that's what we're going to do for this one. So I've got 2 to the x. We're going to take, I'm going to use base 10 here. What did I just do? All right, sorry. I'm going to use base 10 here, so I can't write over there. So it's going to be, we're going to take log base 10 of 2 to the x is equal to log base 10 of 3. Take that log of both sides. Then use our power property here, which says that we can pull that exponent, that power down, and that's equal to x times the log base 10 of 2, and that's equal to log base 10 of 3. So then if I want to solve this for x, I'm going to divide both sides by log base 10 of 2. So what I'm putting in my calculator is going to be log base 10 of 3 divided by log base 10 of 2. So if I pull up that calculator in Canvas so that you can see it, and hopefully I can get my what it looks like, because that's probably what you're going to be using. Here's my assignment. If I pull up that calculator, how do I put this in? This log base 10 of 3 divided by log base 10 of 2. We're going to do log base 10 of 3, close my parentheses, divided by log base 10 of 2. Here it doesn't matter if I close or not. I'm just going to go ahead and do that. And then that's the answer that I'm typing in for my answer choice. It says round to the nearest hundredth, so that would be 2 decimal places. So your answer to number 1 should have been 1.58. So while I'm in here, I might as well type it in, 1.58 for that answer to number 1. All right, now I'm on to number 2, which is very similar, except for I have to do a step before I can do the log. I need to bring this 8 over to the other side. So I've got 10 to the x power equals 21 minus 8 is 13. And now I'm ready to take the log of both sides. So you can do any base you want, but because this is a base 10, it's going to, I would use base 10 or base e because that's what's in on the calculator in Canvas. But if this is base 10, this is really just equal to x, this left side. Or if you don't see that, then bring this down and use the same solving steps that happened on number 1. But log base 10 of 10 is really just equal to 1. So our answer is just going to be that x equals log base 10 of 13. All right, and then again, pull that calculator or go to that assignment in Canvas. And if you don't believe me that log base 10 of 10 is 1, and you want to do log base 10 of 13 divided by log base 10 of 10, you end up with 1.11. Or we could just do log base 10 of, clear that out, log base 10 of 13, and we get that same 1.1. So I'll go ahead and type that answer in here for our answer to number 2. All right, number 3, same idea. We're going to take the log of both sides. I'm still going to use base 10. You could use that, or ln. You really could use any log, but again, I'd use one that I can easily put in the calculator. All right, so we end up looking like this. We've got log base 10 of 9 to the 2x power equals log base 10 of 66. So I'm going to use that power property that says that this is equal to 2 times x times log base 10 of 9, which is equal to log base 10 of 66. And our job now is to get that x by itself. So we're going to get that x by itself by dividing by, and we can do this all at once, or you can do it in 2 separate steps. It doesn't matter. We have to divide by the 2 and the log base 10 of 9. All right. If you're going to do them together, just be careful when you're putting it in your calculator. So if I go back into Canvas, let me slide this so you can see what I have written down there. and I put this in my calculator, all right, if I do log base 66 divided by 2 times log base 10 of 9, this is not going to give me the right answer because it goes left to right. So that whole thing, I'm dividing by both of those. So I want to make sure that I do log base 10 of 66 divided by, open up parentheses, 2 times log base 10 of 9 to get the answer, which is going to be 0.95 for number 3. So go ahead and type that in, 0.95. All right, so number 4, same idea except for choosing E. Just remember E is a number. All right, so on this one, because it's E, you can use log base 10 or log base E. I'm going to use natural log base E, because what's going to happen here is when I use my power property, which would bring this x plus 1 down from the exponent, equals the natural log of E, this is equal to 1, so that can go away. So what I'm left with here is that x plus 1 is equal to the natural log of 15. So if I want that x by itself, x plus 1 equals the natural log of 15, then I need to subtract 1 from both sides, and what I'm going to type into my calculator is that I'm going to find the natural log of 15 and take that value and subtract 1 from it. All right, so if I go back here to my calculator, all right, now I'm using natural log. One real quick, just to make sure, remember natural log of E, I promise that it's 1. The natural log of 15, and then subtract 1, and it's going to give us our answer, which is 1. Where's that problem? So I can type it in, 1 point, rounded to the nearest hundredth, 1.71. All right, 5, same thing, but before I do my logs, I need to get the exponential part isolated. So I want to bring that 12 over first. So I've got 3 to the x plus 5 power is equal to 30. All right, 12 plus 18. Now I'm ready to take the log, and it doesn't matter which one I do, but I'm going to go ahead and do base 10 here. The log of both sides, as long as they're the same base, it doesn't matter. Use my power property, and it becomes x plus 5 times the log base 10 of 3 is equal to the log base 10 of 30. So I'm going to do 2 steps here. I'm not going to distribute. I could. I'm going to first divide by that log base 10 of 3. So that's going to cancel that on this side. All right, so I've got x plus 5 equals log base 10 of 30 divided by log base 10 of 3. Sorry, that says log pretty terribly. And now I'm going to bring that 5 over. So after I figure out what that number is, I'm going to subtract 5. So again, let me pull up Canvas and the calculator and scroll it down so I'm ready to type it in. And I'll go ahead and move it over so that we can see. We're going to take the log base 10, and I feel like I wrote the wrong thing. That should say 30, of 30, and divide it by the log base 10 of 3. So 30 divided by log base 10 of 3, and then subtract 5. Make sure that I close that parenthesis there, or it will be subtracting the 3 and the 5 first, and then hit equals to get our answer, which is going to be negative 1.90. All right, our next one, number 6, solve the equation. And same thing, nothing to move, nothing outside the exponent, so we're ready to take the log of both sides. So I've got log base 10 of 12 to the 4 minus x power equals log base 10 of 20. All right, use that power property. Make sure you put that exponent in parentheses because the whole exponent gets multiplied by the log of 12. So I've got 4 minus x times the log of 12 is equal to the log of 20. All right, again, I've got options here. I could distribute, then do my solving steps, or I can divide. I'm going to divide because it's going to make it easier to plug in the calculator, at least in my opinion. I'm going to divide both sides by the log base 10 of 12. So then what I'm left with is 4 minus x equals log base 10 of 20 divided by log base 10 of 12. Now, I'll be honest with you, this isn't my favorite type of equation to solve. I like it to be x minus 4, not 4 minus x. So we've got two things that we have to do here. We are going to have to bring the 4 to the other side. All right, it might be tempting to add it, but if I add it, it would be 8. So we're going to subtract 4, and then I'm left with negative x equals log base 10 of 20 divided by log base 10 of 12 minus 4. So if I want to know what positive x is, after I get that answer, I need to divide it by negative 1. Or change the sign. If it's positive, make it negative. And if it's negative, make it positive. All right, so let's go back to our calculator here in Canvas. All right, got lots of stuff to do here. We are going to take the log base 10 of 20, close my parenthesis, divide it by the log base 10 of 12. We're going to subtract 4 from that and get an answer, and then divide that answer by negative 1, which hopefully we don't really have to do because it's just going to make that negative 2.7944 into a positive 2.7944 for our answer here to number 6. All right, so to the nearest hundredth would be 2.79. All right, just a couple more of these. Number 7. On this one, I need to get this part by itself before I do log or natural log. So I'm going to move the 5 to the other side first so we can isolate the exponential before we do the log. So that's going to be e to the 3x is equal to 1. So then on this one, because it's base e for the exponential, I would use natural logs. There's nothing wrong with using common logs, but if I use a natural log, I know that the natural log of e is equal to 1, so when I use this power property, I end up with 3x times the natural log of e, and what's in those brackets is equal to 1, so I can just forget that's even there. So I have 3x equals the natural log of 1. All right. And then to solve this for x, divide both sides by 3. So what I'm going to figure out is what the natural log of 1 divided by 3 is. All right. So if I pull up Canvas, slide it over so you can see it, we are going to take the natural log of 1. Nope, let me clear that out first. The natural log of 1, and we are going to divide that by 3, and we're going to get 0, which might seem a little weird, but let's think about this. Something plus 5 has to equal 6. Well, there's one answer that circle could be, and that is 1. 1 plus 5 is 6. So therefore, what do I need to take e to what power to get 1? Remember, any number, any non-zero number to the 0 power is 1, so our exponent needs to be 0. So to make it 0, and it's 3 times x, our answer for x is going to be 0. All right, for some reason I didn't put number 8 on here, so let's go back to our Canvas screen and we'll just write on there. All right, so number 8. If I get rid of my calculator for a second, it says solve the equation, round to the nearest hundredth. So on this one, we got to do some steps before we can solve it. So we're going to, before we can do the log, so we're going to subtract 7 from both sides, and I have negative 2 e to the x divided by 2 equals negative 6. Then I'm going to divide both sides by negative 2, and end up with e to the x divided by 2 power is equal to 3. And then because it's e, I'm going to take the natural log of e to the x over 2 power is equal to the natural log of 3. I'm going to go up because I'm running out of space here. So if I use my power property, this is x divided by 2 times the natural log of e equals the natural log of 3. This, remember, is 1. So x divided by 2 equals the natural log of 3. If I multiply both sides by 2, then that's going to give me my answer. So I'm going to pull my calculator out and do 2 times the natural log of 3 to get my answer for number 8. All right, so if I come up here and do 2 times the natural log of 3, and the answer to this one, rounded to the nearest hundredth, is going to be 2.20, because that 19 is going to round up with that 7 behind it. All right, we get a break from doing some calculations, and we're going to answer some questions about the graph. So I told you a couple weeks ago that logs were exponentials of inverses of exponential. Let me get life right here. So here, let's think about what we know about inverses. Inverses, we find them by switching y and x. The y and x coordinates just switch. All right, here's the graph of y equals 2 to the x. That's what is in blue. In purple is the log base 2 of x. All right, and if I drew that line, remember these reflect through the line y equals x. If I sketch that line in there, it's a mere reflection over that line. Let me go ahead and sketch that line in there. Get a lighter color. If I sketch in the line, trying my best to make it have a slope of 1 and go through there, see how that reflects perfectly across that line. All right, oops. So we're going to use some drop down. So I'm looking at the blue function here, g of x. Any exponential function, remember that I can put anything in for my exponent, so our domain is all real numbers. The range is not, because when we take 2 to some power, and we're always going to get a positive number, so our range is going to be y is greater than 0. So now we get to select all statements that are true about inverse functions. The range of a function is the domain of the inverse. That is true. We just switch x and y, and domain is x, range is y. The inverse functions reflect through the line y equals x. That is also true. The domain of a function is the range of the inverse. That is true. We're flipping our x and y. Inverse functions reflect through the x-axis. That is not true. They do not reflect across the x-axis. If two functions are inverses, they have the same domain. They might, but they don't have to. These two do not have the same domain. The blue function has a domain of all real numbers because it covers the entire x-axis, because there is an arrow here and an arrow there. So this arrow is going to the left, this arrow is going up and to the right. We've got left and right covered. But this purple function does not have a domain of all real numbers, because this arrow is going down and this arrow is going up and to the right. We don't have any left going on, so they do not have the same domain. And then lastly here, an inverse function is found by switching the x and y values. That is true. All right, use the graph and what you know about inverses to make the following statements true. So if I use number 9, they're just going to flip-flop. But I was a little bit mean on this one. When we're talking about domain, it has to be x and not y. So for our logarithmic functions, if we had to graph those, which we're not going to spend much, if any, time doing because we are in the home stretch here, the domain is restricted. If I look at this values, this is starting when x is 0 and x values are getting bigger. But the range is all real numbers, so we can get anything for an output, but we can't input a negative into a log. All right, then 12 and 13 were really difficult, okay? So this says on 12, use the graph to explain why there's no solution. We've done this problem before, but it didn't have this extra line on here. If I forget about the purple function right now, if I were to want that blue graph to get down to y equals -3, that's never going to happen because our range is our y values are greater than 0. So there are a couple things, and a lot of you guys said some different things which were pretty much spot on, is that we could say something about the blue graph will never intersect the line y equals -3. We could say something with extent to that Negative 3 is our output, right? Our input's x, our output's over here. That the output, oops, get that right, or the range is y has to be greater than 0, so it's the function cannot have an output of negative 3. All right, so just some things there. All right, 13 is looking at the purple graph. So if I solve this equation, this is the steps that I would be doing. All right, now you might not even do this last step. You might just try to type that in your calculator. What's going to happen if you type this in your calculator, let me pull it up, if I tried to do the log base 10 of negative 3 divided by the log base 10 of 2, it's going to say not a number. All right, is what I think that means, but I could be wrong. It doesn't work. Okay, it gives us an error message. In my calculator, it would say a domain restriction if I were using my graphing calculator here. This doesn't work. So we're going to try to use the graph for about why this doesn't work. If we're looking at the purple function, look at our x values. The x values have to be greater than 0. All right, if we look at this purple function and we think about what the domain is for the purple one, the domain is going to be anything that is greater than 0. So our inputs domain has to be greater than 0. Here it's asking us to input negative 3. Negative 3 is not in the domain, so it can't have an answer. All right, so some of you guys, you can't take the log of a negative. That is our important takeaway from this. All right, but if we're looking at the graph, how can I use the graph to say it? Is that negative 3 is not in the domain of f of x, so therefore it does not have a defined solution. All right, a couple more. I think I got these actually on the slideshows, so I'm going to minimize this and get back to it. When I'm looking at which ones have no solutions, so 14 is building off what we just looked at. We can't take an exponential of a negative when we're trying to do we can't get a negative output from an exponential or 0. Or when we're solving this using logs, we can't do that with a negative. So the number that this exponential is equal to has to be a positive number. So there are two equations that have no solution. The first one is fine. 6 is positive. We're good. This side doesn't matter. As it's exponential, that output, remember the domain of an exponential function is, back it up, I said domain, I meant range. The range of an exponential function, our outputs have to be greater than 0. So what I circled here are the outputs. They have to be greater than 0. So when I'm looking at this first one, 6 is greater than 0. So that has a solution. But this second one does not have a solution because negative 2 is not greater than 0. The third one has a solution because 12 is greater than 0. But the fourth one does not because it's equal to 0 and 0 is not greater than 0. All right. Moving on to 15, log base 3 of x is only defined for values of x that are greater than 0. Yes, if we're trying to take the log of something, that number has to be greater than 0. All right, and what those graphs were trying to show to you, and it might have been kind of confusing, and I apologize for that, is that it's the range of the exponential is our domain of our log. All right, so if the range of an exponential says it has to be greater than 0, then the domain of our log mean our inputs also have to be greater than 0. So there is a domain restriction, something we haven't had for a while. All right, number 16 is a word problem. Jill invests $2,000 into an account that receives 3.5% interest compounded continuously. So as soon as I see compounded continuously, here's our equation that we're going to use that you were hoping was not coming back. We're just going to do a couple real quick things with it yesterday and today. How long will it take for the account to have a balance of $3,000? So we're going to plug in what we know and solve for the variable. So 2,000 is what she starts with. That is the principal. That is P. All right. E is a number, so that's going to stay in our equation. The interest rate, R, is 3.5%. But remember, when we put this into our equation, we turn that percent into a decimal. How long will it take? We're solving for t. for the account to have a balance of $3,000, and A is how much we have at time t, so that's going to be 3,000. So we've got this beautiful equation here, and here's the reason that we have to know how to solve these, that we are going to solve for t. So I've got to get rid of the 2,000, get this thing out of the exponent, then solve it for t. So first step is to divide both sides by 2,000. All right, now you might be like I was when I was your age and really want a calculator for this, but you don't need a calculator for this. Those zeros are all going to cancel, and we end up with 3 over 2. I'm going to move up here where I have a little bit more space. 3 over 2 is 1.5, or you could just leave it as a fraction. All right, so this is where we're at. So now here's the new thing that we haven't been doing just learning how to do right now, is that we need to get the variable out of the exponent. So that's where logarithm comes in. Since this is base e, I would use natural log. You don't have to, but I would use natural log because something nice is going to happen with the ln of e. So the natural log of 1.5 is equal to the natural log of e to this power. So I'm going to do my power property. This thing's going to come out in front. This is 0.035 t times the natural log of e. Well, the reason that I use natural log is because the natural log of e is equal to 1. So this just simplifies to, and you could probably skip this step. If it looks like this and the bases are the same, this simplifies to the exponent. All right, so we've got the natural log of 1.5 is equal to 0.035 times t. So what we have to do to solve this for t is take the natural log of 1.5 and divide it by 0.035, and that's going to give us our time. All right, so if I pull Canvas back up so I can grab that calculator, I can go ahead and answer these questions too if I wanted to. But for the calculator, I'm going to take the natural log, maybe I should clear that out, natural log of 1.5, close those parentheses, divided by 0.035, and I think it says round to the nearest year, and I hit the wrong button. I erased the whole thing, so sorry, you got to watch me type it in. Natural log of 1.5 divided by 0.035, hit equals this time, and then we're just going to round this to the nearest year, so it's 11.58, so I'm going to round that to 12. All right, so I know these are different. You've never done anything like this before. Some of you might have been using this method to solve the ones that we could get the bases the same. But now you have two ways to do it, even if you could get the bases the same if you like this method better, because it takes less maybe mental math to figure and less knowledge of those powers to get them to the same, then this is a definite way that you could go. All right, so please take a minute to watch the video for today. It's a little bit shorter. Sorry that you ended up with 2, and then try the practice for today. Also, don't hesitate to email me or